Okay, hello. This is part 2 of the video on polynomial long division. If you haven't looked at part 1 already, where I had a go at this example over here, please have a look at it. It'd be quite helpful. What we're going to do here is a harder example. So let's have a look at this question here. So here I've got x to the power 5 plus 3x to the power 4 minus 2x squared minus 3 divided by x squared plus 1. Okay, what I said before was I wanted to check whether or not I have all consecutive powers of x. So let's have a look in my dividend. So just a reminder, I'm just going to write it up here again, dividend. So let's go. X to the power 5, 5, 4, whoop, no 3. So here what I'm going to need to do is I need to leave a gap for x to the power 3. Let's continue, x squared. Oh, there's no x term, so I'm going to have to leave 2 gaps actually. So this one's even trickier. So I'm going to have to leave 2 gaps for my x to the power 3 and x to the power 1, just my x term. Okay, so even in my dividend, we've got a few issues. Okay, let's check the divisor. So my divisor is it's a polynomial that I'm dividing into. So let's have a look. X squared. Oh, no x term. So I need to leave a gap for the x term, and I've just got 1 at the end. Okay, cool. So let's write this out. Okay, when I'm doing this, I'm just going to write x squared. I'm going to leave a gap here. Now, with your divisor, the gap isn't super important. I'm going to say that with like a bit of a kind of caution. As long as you remember that you're multiplying, when you're multiplying by the whatever is up in your quotient, the green term, that you leave a gap. So here I'm going to actually write it as x squared plus 1, and I'm dividing into x to the power 5 plus 3x4. I don't have an x cubed term, I'm going to leave a gap. Minus 2x squared, don't have an x term, oh, nearly extend this a bit more, I'm going to leave that, minus 3. And so when I end up doing this division, I'm going to actually draw these down and just leave gaps to show that I've got nothing in those x cubed and x term. Okay, I'm going to erase that gap. Okay, cool, I've got that. Now, as I said before, we're going to start by looking at, okay, how many times does my leading term of my divisor go into the leading term of whatever's in my dividend that I'm dividing? So here I've got x to the power 5 divided by x squared, which will give me x cubed. So I'm going to multiply x cubed into my dividend. Not my dividend, my divisor. So I'm going to get x to the power 5. Okay, when I times x cubed into my divisor, I've got x to the power 5 plus x cubed. The reason why I left those gaps is so that I can actually line this up really nicely. Because when I do that 1 times x to the power 3 or x cubed, I'm going to have this x cubed term. I'm going to line it up nicely so that, oh, that's a bit long. Line it up nicely so that I've got, that matches up and I don't confuse my x terms. Because when you rush this, there might be a potential problem where when you're rushing it, you end up writing x cubes and x squareds, and those 2's and 3's, they kind of look similar if you're rushing it, so you might end up making a mistake here or there, and the division is going to go wrong. And we don't want to have those divisions. We want to minimize our errors, potential errors. Okay, so once I've done that, I'm going to subtract the 2. Hopefully you'll notice the leading terms will cancel out. Then I'm going to drag down this x4 term. When I drag down this x4 term, it's not subtracting with anything. There's nothing underneath it. So I'm subtracting 0. And so that's the same as just me writing here, 3x to the power 4. And I'm going to subtract this x cubed term. Now the x cubed term is not subtracting anything up here. So that's the same as just 0 minus x cubed. So here I'm going to have negative x cubed. Now as you notice, when we did our division, we have 1 term, we have a gap in between, and then we have the other term, because we have x squared, no x term, plus 1. And so when I'm doing this next division, I'm going to actually need to drag down my, where is it? X squared term. So I'm going to subtract 2x squared. I'm going to drag that down for this next part. Okay, once again, look at my leading term of my divisor, look at the leading term in my dividend, whatever's left there. I'm going to figure out how many times does x squared go into 3x to the power 4. Or just, that's the same as saying 3x4 divided by x squared. Well, with that, I'm going to have plus 3x squared. Okay, and that'll give me 3x to the power 4. And if I write plus 3x squared up here, I need to multiply that into my divisor. When I multiply it into my divisor, what do I get? So I've got 3x to the power 4 plus 3x squared from when I multiply this plus 1 by this 3x squared. So let's put that in. Plus 3x squared. And I line it up with my x squared term. I subtract the 2. Okay, so I'm subtracting the 2 now. Here, I'm going to start from the left. Okay, I'm going to start from the left. These x4 terms will cancel out. Perfect. Next part is I've got this negative x cubed term. It's not subtracting with anything. There's a gap here. That's the same as subtracting 0. So I'm just going to write here negative x cubed. Okay, and the final bit is negative 2x squared plus 3 minus plus 3. So here I'm just going to have negative 5x squared. Now what I'll do is I would have dragged down this next term. If I drag down this next term, there's nothing there. So I'm dragging down a nothing. So I'm going to leave a gap there. I'm going to leave a gap there. Okay, continue this process. I'm going to look at my leading term in my divisor, so my x squared plus 1. I'm going to look at my leading term in whatever's left in my dividend, negative x cubed. How many times does x squared go into negative x cubed? Well, it goes into it negative x times. So here I'm going to have negative x cubed. If I multiply negative x into my divisor, I'm going to have negative x cubed, which I already put down, minus x. Minus x. Okay, cool. Now I'm going to subtract the 2. The leading terms cancel out. Perfect. This negative 5x squared, as we've noticed from all the previous part from up here and over here, it's not subtracting with anything. So I'm just going to have minus 5x squared. Negative 5x squared, there's nothing it's subtracting with, so I'm just going to subtract 0, negative 5x squared. And if I'm subtracting, I've got 0 minus negative x. There's nothing to subtract from this negative x squared. So I'm just going to be, it's going to be 0 minus negative x. So that's just the same as plus x, and I'm going to drag down the next term, minus 3. Okay, I'm going to do this process again. I'm going to look at the leading term in my dividend, leading term in my dividend, so this 5x squared, negative 5x squared. Look at the leading term in my divisor. How many times does x squared go into negative 5x squared? It goes into it negative 5 times. And so here I'm going to have negative 5x squared. And when I do that, I'm going to multiply my negative 5 into this divisor. So we've got negative 5x squared minus 5. Okay, I'm going to subtract the 2. Okay, so I think a few things skipped in the video. I apologize for the sudden jump. So I think we finished off just before I cut, because I accidentally pressed the button. We got to this part. We got to this part down here. We had that negative 5 multiplying into x squared, this negative 5 over here, multiplying into this x squared plus 1. And so we got negative 5x squared minus 5x down here. Now, what we did was we subtracted, and so we got this result x plus 2 at the end. And so what I did on the right here was just rewrote that using my division theorem. And so I wrote it as my original function, my original polynomial, x to the power 5 plus 3x to the power 4 minus 2x plus 3. So that's your p of x, if you remember from that notation, is equal to x squared plus 1, my divisor, or my d of x, times x cubed plus 3x squared minus x minus 5, my quotient up the top over here, my quotient, plus my remainder that was down the bottom here. So remainder x plus 2. So that went through those two examples. Hopefully that makes a little bit more sense. I'm going to go through actually one more, and this is a little bit trickier, and this is a one where we use a bit of problem solving to help us find a few answers. So here, we've got a polynomial, x to the power 4 minus 2x cubed minus 20x squared plus mx plus n is exactly divisible by x squared minus 5x plus 2, and we need to find m and n. Okay, let's just break down this question. So we've got a polynomial over here. This is our dividend. This is what we're going to divide by for this question. It is exactly divisible. Now this is, when you see this word exactly divisible, what does it mean? Well, if it's exactly divisible, that means that our remainder is equal to 0. Think about it. If a number is exactly divisible by another number, so let's say, e.g., 144 divided by 12. 144 is exactly divisible by 12 because 12 goes into 144 a perfect whole number of times. 12 times. There's no remainder. There's a remainder of 0 actually. And so if I want to have it being an exactly divisible number, exactly divisible, my remainder is going to be equal to 0. So I'm going to actually use this fact, and it's going to help me find these missing values here, m and n. Okay, let's have a go at doing this question. So I'm going to set it up. My polynomial here. I'm going to check that all the powers are in place. So 4, 3, 2, 1, 0. Okay, I have all my powers of x. I'm going to check my divisor here. 2, 1, 0. Perfect. I have all my powers of x. Okay, now that I've done that, I'm going to set up my long division. X squared minus 5x plus 2. I'm going to divide into that. I'm going to divide x to the power 4 minus 2x cubed minus 20x squared plus mx plus n by this number. Okay, let's use this process that we've been doing. Leading term of the dividend and look at the leading term of the divisor. Okay, how many times does it go in? X squared times. So here I'm going to have x to the power 4. I'm going to multiply my x squared term into my divisor. X squared, x to the power 4 is when I do x squared times x squared, this leading term, minus 5x cubed when I multiply this negative 5x plus 2x squared when I multiply this plus 2 by x squared. Okay, so that's that first part. Okay, cool. Now that I've done that, I'm going to subtract. Subtract the 2. Bam. The leading terms will cancel that. We're good there. Negative 2x cubed minus negative 5x cubed will give me 3x cubed. Great. Negative 20x squared minus positive 2x squared will give me negative 22x squared. And then the next part, I just drop down the next term, plus mx. Okay, cool. Leading term. Look at the leading term again. X cubed, 3x cubed. How many times does x squared go into 3x cubed? It goes into it 3x times. So I'm going to have 3x cubed when I multiply 3x with x squared. And let's do the same for the rest of the terms. Minus 15x squared plus 6x. And so negative 15x squared comes from 3x times this negative 5x. 6x comes from this 3x times positive 2. Okay, so that's that next part. Okay, now I'm going to subtract. And this is where it gets a little bit messy because we have a few algebraic terms. We have this m and this n, which makes it a little bit trickier. But still, we're using the same process. I'm going to subtract. The leading terms will cancel. Negative 22x squared minus negative 15x squared will give me negative 7x squared. And here I'm going to have mx minus 6x. So I'm going to have it in terms of x. This is going to be m minus 6. m minus 6. I'm going to drag down the next term. Plus n. Okay. Here we go. Leading term, leading term. Let's have a look at them. X squared goes into negative 7x squared, negative 7 times. So I'm going to have negative 7x squared. And once again, I'm going to multiply this into my whole thing here. Oh, I moved a few things. Plus 35x minus 19. So here I'm going to have these two will cancel. M minus 6x minus 35 is going to be m minus 41x. If you want to check, you can expand that out. M minus 6x minus 35x. So that's mx minus 6x x, mx minus 41x. And I think I'm about to run out of time for this video. I'll continue this example in the next one.